Six Sigma is basically a set of tools which we use to maximize the output, or we can say we use to maximize the profit and to make our business more successful. It is basically the right understanding of your customers' need, what our customers expect from us, and how to make use of entire system or machinery or workforce efficiently. So basically analyzing, improving and re-engineering the processes to increase the customer satisfaction is a Six Sigma. It is a philosophy. If we talk about to excel the business, it includes basically the study of cost reduction, how to improve the productivity, and how we can grow the market share. The cycle time reductions, defect reduction in our production, and how to improve the basic quality culture in the industry. There are so many questions like this which are being answered by the Six Sigma and the tools we use and basically the philosophy of Six Sigma. So here is the brief history of Six Sigma. It basically started in 1987 and Motorola's communication was the pioneer. They wanted to improve the productivity by comparing the performance of the products of the production output with the customer requirement and to achieve ambitious target of near perfect. The near perfect term means that they wanted to make 99.9997% defect free parts, and this means they needed 3.4 parts defected parts in 1 million, like no more than 3.5 parts can be defected if we manufacture 1 million items or if we manufacture 1 million products. In this case, if we manufacture 1 million mobile phones, then out of 1 million, not more than 3.5 parts should be defected. If we can achieve this, then we can say that we have implemented Six Sigma. This Six Sigma process or the systematic approach to process improvement to attain Six Sigma quality that is spread throughout the company with strong backing from the chairman at that time. The Robert Galvin was the chairman. He was very impressed by this idea because it was really very revolutionary. And once they started to implement the Six Sigma, it was a very hard working job, and the entire company was involved. Every single person working in Motorola was involved in this project. Once they launched the project, the outputs and the results were very interesting because we don't realize, but if we manufacture 100 products and out of 100 we have like 5 to 6 parts that defected, then what we don't realize is basically those defected parts cost us a lot, and if we multiply those 100 parts with million, just imagine those defects will be multiplied as well. So if 8 parts are defected out of 100, then just imagine how much parts will be defected out of 1 million, and the amount, the material, the uh, energy spent on those defected parts goes wasted. So idea or target was to eliminate the those defected parts. Anyways, they applied this methodology, and what happened after some years, they got almost the profit, or they were able to save almost 14 billions, and of course annual rate share rate was 21.3% in the market. They won the some award as well, the Baldrige Award. It is basically a quality award in industry, uh, any industry which is working very carefully to improve the productivity and to maximize the profits by implementing revolutionary tools. are basically the uh, people who can win this award. Well, after the successful implementation of Six Sigma and Motorola, the other companies, Honeywell, basically they manufacture different engineering equipments, and General Electric, of course, you know this company, you might know this. They implemented these techniques as well, and the profit or the outcome was remarkable. These are basically six themes of Six Sigma, like what exactly Six Sigma is doing and which areas are being impacted, how it is important, how and why it is basically important to implement Six Sigma, why first of all the customer is the prime focus, then it is a data driven management, process focus is of course one of the most important part, proactive management, boundaryless collaboration. Let's start from the first theme, which is basically focus on the customer. Okay, this is the first part or first theme, and we need to understand that the customer is the basic target, and the customer is basically the prime focus. We always make sure the first priority or the top priority is the satisfaction of customer. And the Six Sigma improvements are evaluated based on how they impact the customer. His requirements are assessed, and the performance of the organization's product is then evaluated against those requirements, which are the basically requirements of our customer, the expectations of our customer. Then we try our best to address all those needs, all those requirements, which are the prime focus of our customer. We try to mold our product in terms or the way our customer wants it. Customer gets the highest priority in Six Sigma organization. There is no doubt in that. An organization that adopts the Six Sigma process to improve all the processes against the requirement of customer is basically the successful organization. The second theme is data and fact-driven management. In this approach, we cannot use or we cannot make decisions based on our gut feelings. We cannot assume anything, or we cannot make decisions on the basis of anyone's opinion. We always need data. Uh, we get the data from the production, we are analyzing the production, then we use that data in specific tools, specific statistical tools, and the results which are being given by those or which are being generated by those tools are used for the decision. The information generated by those tools must be used to make the decisions on processes or process improvement. The third theme is the process focus. As the name states, it is basically about the focusing on the process. We need to understand the process deeply if we want to make an improvement in it. So if we are manufacturing anything, there must be a process which we need to follow. The product or services are created or produced by a process, definitely, whether it is being designed or if we are even preparing an invoice, if we are going to answer customers' complaints, or if we are going to solve a problem, there is always a process. We basically map all the activities involving all the sequences of the steps, and then we analyze. We process, basically we map the processes using charts or papers, then we definitely can understand them better. And definitely once we understand those processes, By mapping them, we can improve them, we can make changes in them in a very better way. So understanding a process fully in order to control or improve is the basic key of leading the success in this Six Sigma methodology or this philosophy. This theme is proactive management, the proactive approach toward the management of a process. It is basically the understanding of the concept that there might be chances our customer will be complaining us about something. So to eliminate, to remove all those complaints before it happens is basically the proactive management of the processes. We know that there are always chances that the customer will be complaining about something. So instead of waiting for customers' complaints, we basically try to prevent those problems from occurring, which is a lot cheaper and less time consuming than try to solve them once complaints are being received. The problem is basically when the customer complains us, we start as a firefighting scenario. We try to eliminate those problems, but while we are eliminating those problems, the damage has occurred. The customer knows that our products are defected, so there is a bad image of our product already in circulation, and it is very important to avoid that chance. It is very important to avoid that bad image or bad name. And how it can be done? It can only be done if we avoid any error or any problem, any chances of defects to occur by using a proactive management or proactive approach. The fifth theme is boundaryless collaboration. Basically, the lack of communication among the functions in organization can cause a lot of damage. Like if there's a lack of communication in some designing or production stages of product, then it will result or it will cause delays or might be redesignings, and the heavy rework can be required to make the product functional. It's like if manufacturer is going to fabricate or manufacture something, then he must know what exactly designer wants. What is the basic idea of designer? So if he is not clear, then there are chances that he might be doing something different or which a designer is not expecting. So to avoid all those trouble, the manufacturer should be in direct contact with the designer. The Six Sigma approach emphasizes process improvement and process redesign through cross-functional teams. The process of concurrent engineering, which basically focus on the involvement of all the functions of an organization in specific project, should be taken care of. It basically creates an environment where people work together and support one another to make a product which is flawless or free of any issues and problems. The sixth theme is the drive for perfection. The basic target of Six Sigma is to achieve 99.997% perfection. That means 3.4 defected parts in 1 million. The drive for perfection always continues because with the keeping changing standards of production or with the changing standards in system, there are always different issues which we can see which comes in our observation. So it is a continuous process of observation and trying to eliminate all the problems which are occurring or which can occur. the potential problems are of course being taken care of in this approach or system as well. As we are discussing Six Sigma, it is important to find out how we can calculate and how we can measure this value. From the table 9.1, you can see different uh, defected quantities or the defects per million opportunities if we have different sigma levels. Let's suppose if we have a sigma level of 3, that means 66,800 defected parts are available or are present in 1 billion items. So the yield percentage or the percentage output of the system or production in that case is 93.32%. That means if the output rate or the products you are manufacturing or fabricating are 93.32% accurate or defects free, then your sigma level at the time is 3. And I think you can relate better now. To achieve Six Sigma, there should be only 3.4 defected parts per million. The only method by which you can achieve 99.9997% yield. Let's discuss these how we can calculate the Six Sigma with an example in the next slide. Alright, the example, uh, let's suppose your printing business prints custom stationery cards or orders. Each order is considered as a unit. And out of 2000 or 3000, you have selected 50 orders randomly and inspected them, and we found the following defects. Number one, you found that the two orders are incomplete. Number two, you found that the one order is both damaged and incorrect. Damaged, like the corners might be damaged, or and incorrect means something is not properly mentioned on the card, or some name or any design which was printed on the card or anything like that. Okay, the third one is basically three orders which you have found with the typos. There are typing mistakes. The question is calculate the sigma level. Alright, let's have a look to the solution. There were basically six defected items, and the one item which had two defects, so we'll count it two times. Hence, the six of the orders have problems, and there are total of 7 defects out of 50 orders sampled. Now we have to find DPU, that means defects per unit, and to find out the defects per unit, basically the method is the number of defects in a sample divided by the number of units sampled. The units sampled are 50. Remember, we discussed that we gathered or we collected 50 out of 1000 or 2000 items. So we inspected those 50 items and we found that there were 7 defects. 7 kind of items have defects. So the result we found is basically 0.14. Now the second part to calculate the Six Sigma is basically to find out the defects per opportunity. What is basically the opportunity is each custom stationery order had 4 defects. We know that: incorrect, typos, damaged or incomplete. So we can say that there were 4 type of defects, and in other words we can say that there were 4 opportunities. Yes, the type of defects or the problems are basically opportunities. And now what we are going to do, we will multiply with this opportunity or the 4 with the total number of items we have selected from the batch. As we know that we selected the 50 items from a batch of 1000 or 2000, so we will multiply 4 with 50 and then we will have total number of opportunities, which is 200. Then we will divide 7, which is total number of defects, with the total number of opportunities. This is how we can get, or we can find out, the defects per opportunity, which is in this case 0.035. Here's the summary of the entire question. I have made it in the form of chart so it can be easily understandable for you. Uh, the defects, number of defects, we know that the total number of defects are 7, and basically the number of defects which you are thinking and it can be confused are called opportunities in this case, which are 4. Now we'll consider the total number of orders considered, which were 40. I repeat, from the batch or lot of 1000 or 2000, we gathered, we collected 50 items and we inspected them. Now defects per unit. Here you can calculate by this method, and we find out the value is 0.140. The defect per opportunity is basically multiplying the opportunity with the total number of orders considered, which is 4 into 50, and the value basically we found is basically 0.035. Now defects per million opportunity. That means calculating these defects in the lot of 1 million items. So uh, you can see the answer is 35,000. 35,000 pieces or items will be defected if we will inspect the lot or the batch of 1 million items. Now yield is basically the output of the process. You can see the from the yield percentage, it is 86%. That means out of 100%, 86% items are good to go, or 86% items are defect free, but the rest of the 14% items are defected. The sigma level can be measured or checked from the yield as well. Let's say from the table 9.1, which was in the start of this problem, if you check 86%, then you will find out that the value of sigma lies between 2.3 to 3. The 86 percentage exists between 2 or 2.3. So you can tentatively find out the sigma from there or from looking at the table. But if you want to calculate the sigma, there is a formula, normal function of sine into yield plus 1.5. You can use this formula on the Excel sheet, and if you will use it, then you can find out that the sigma level is 2.6%. But again, the simple method is to check from the table, and you can write the tentative sigma level by comparing the yield percentage with the table number 9.1. I repeat that. There are so many advantages of implementation of Six Sigma. Some of them are stated below. The first one, obviously, is basically defining customers' requirement clearly. The prime focus of Six Sigma is to exactly better understand what the customer requires or demands from us. Obviously, if we know better, then we can manufacture or prepare or fabricate a product in a better way. And if we can satisfy the customer need by fabricating a specific product, then definitely our demand will be huge and the profit will increase. The second part is to define a metric, to provide a metric to define the quality of process. It is basically about the quantization of the processes. We need to make, or we need to define different tools of Six Sigma for our processes, and by implementation of those tools we can quantify everything in our entire process. We can definitely calculate the inputs, the problems, the error, and the outputs, which is a plus. The third part is the third advantage is provides a link to an ambitious goal. Just imagine 3.4 defects per million. That is a huge target or a goal for any organization to achieve. Like if you are going to if you are going to manufacture 1 million mobile phones, only three or four phones can be defected, but not more than that. So it definitely set a new target to achieve for any organization. There are three ways or three different strategies which system recognize financing process quality. The strategies are used as per the scenario. If we are already working on the manufacturing of a specific product, then we'll be using process improvement strategy because we already have implemented the processes. Now we just want to improve them. And if we want to launch a new product, and if you we want to just redesign a product, then we'll be using the second strategy, and of course the project management. Let's look at these three strategies in next slides. Process improvement is basically to study the already implemented process to find out the specific problem which we are having, due to which we are having the defected parts. So, in other words, we can say the scenario represents the situation where only incremental changes to the process is required. That means we are not going to design a new process, or we are not going to implement a new method of manufacturing or fabricating something. We are just going to make small changes to enhance the output or to reduce the rework or defects. Process design or redesign is something more than just a process improvement. In this strategy, we can change the entire process related to something, or if we are fabricating something by using a specific process, then we can change the entire strategy of manufacturing or fabricated that thing. This strategy is not just for the incremental changes, but it sometimes may be necessary to revamp an entire process, I said, because incremental improvements will not produce enough of a desired result. So we have to reconsider designing the entire system again. Hence, we take time out and we re-engineer the entire system. We work on the improvement of system on the papers. We find out the basic problems which we were facing before, and then we try to make a design which is free of all the previous problems we were facing. We can use or change the technology uh, just to make the product which is as per the expectations of customer. As it is stated in this strategy, the processes are documented and the customer needs are defined and updated on a regular basis. The basic purpose of this strategy is basically to document everything related to the process. With whatever is linked to the process, we make sure to document that. By documenting the entire process and all the details, details like what are the outputs, what are the inputs, uh, is there any anomaly in the inputs or outputs or in the process, like if we were manufacturing 1,000 parts per day and we were having not more than one or two pieces uh, which were defected, then suddenly we start to have more than 2 to 3 pieces with defects. Then of course it is documented, so we take the quick action to find out the problem and we try to eliminate as soon as possible. The basic advantage of documentation is basically we have a record, and the records are very important, or they play a very vital role in implementation of Six Sigma. Whenever we are going to implement Six Sigma in any system, we make sure, or we first of all establish a system of the documentation and a record keeping. These two improvement processes basically are linked with the strategies which we have just discussed. The first strategy was basically process improvement, and that strategy is the one which we commonly use in the industry because all the processes are implemented and everyone is working on those processes a long time now. So we always try to keep improving those processes. For that, what type of improvement we need? Basically, we call it DMAIC. It's like DMAIC, and D is for define, measure, analyze, I improve, and control. Then the other strategy in which we design or redesign the entire system, or we can say in other words that in which we establish or we make or create a new process that in that kind of strategy we use the approach or the process called DMAGI. In this process we basically replace A and I with E and D. E is basically explore and D is for develop. Like we explore different processes and then we develop some and implement. And like in the previous method, DMAG, we already analyze or measure the processes, then we try to improve them, and at the end we make sure to establish a system to control them. But in DMAG, we explore, we find out new methods of the processes, some are already existing processes, then we develop an entire system for the implementation of that process, and at the end, definitely we can say that we have implemented something. We make sure that the process we implemented in Dimeti is defect free, or definitely if we are implementing Six Sigma, so no more than 3.4 defects per million. Here is basically the chart which explains these two improvement processes. The first one, which is DMAG. Let's look at the first part, which is define. Well, we always start from defining the problem in the system. We must know that what are the requirements, or we have to set the goal of the project. Then comes the measure phase. In measure phase, we try to validate the problems. We try to measure the processes or the material involved in the process. We try to calculate every single thing which involves the process. Then it's like basically sometime calculating the time and motion study, how much material is required for the specific process, how much time is required to drill a specific hole, or how much time is required for the tapping. So all the measuring occurs in this stage. Then comes the analyze stage. In analyze stage, we basically make a hypothesis and we try to validate that hypothesis. Basically, hypothesis is like let's suppose we are observing the process of hiking shoes manufacturing, and the problem we were facing was basically that the soles were not properly sticked. So you can just guess that, or you can just assume that the hypothesis, you can make a hypothesis that the not the proper sticking is not happening because of the glue issues or basically the stitching issues. So this is the hypothesis you have made. Now it is time to validate the hypothesis. You do something, you check the a shoe with the specific type of glue the manufacturer is using, or the if they are using a machine for stitching, then you observe that, or you look at the machine, you find out the or measure the result, check the measured results. This is how the validation of the process is done. Then comes the improve phase. Now you know that let's suppose the glue was the issue or a stitching was the issue. Let's suppose we found out that the glue was the issue. We try to use different type of glues for different type of shoes with the different weights or different size. Then we check, we manufacture or fabricate the shoe, and then we check either the sole is working properly, sole is properly sticked or not. If it is sticked, then that means there was something wrong with the glue and we have solved the problem. Now time to standardize that problem or the steps we took. We basically have been documented the entire process and we know now that what weight requires which kind of glue. There are standards available, so we will make a standard of that. Then comes the control phase or control stage. It's like if as we are monitoring the entire process now after the implementation of Six Sigma, we will be looking at the charts. Like if there are out of 10,000 only one pair of shoe is defected, as soon as we find out that the number of defected shoes is increasing or rising, or if there was a specific process which needs more and more rework, then it is alarm for us and we go to observe that stage again, and we try to eliminate the problem, we try to correct the problem as needed. Here is the second process, Jamari. We know that we implement or we use this process when we are going to create a new product, or we're going to design or redesign a specific product. So first of all, we'll try to define a scope, like what our customer needs or what our customer wants. If I am an engineer and going to fabricate or manufacture a product, then I need to understand the exact requirements of my customer. In that case, my customer can be my boss. What is he expecting from me and what he wants me to basically do with the specific process. So once I have understood the problems, then once I have understood the scope, then I'll move to the next step, which is measure. Now I know that my boss wants me to establish, let's suppose, a manufacturing or fabrication facility for hiking shoe. Then what I'll be doing, I'll be measuring every single thing or every single entity involved in the process. I will be measuring the I will be measuring or calculating the ingredients or the raw material I'll be needing, from where I'll be needing, what will be my resources, and which how many steps will be involved in the fabrication of this process. I'll be needing some cutting facility to cut the leather. If I'm going to manufacture a leather shoe, then I'll be needing a stitching or gluing facility. Which kind of glue, how it will be sticked, and how stitching will be done. Either it will be hand stitched or I am needing to use machines for that. I need to calculate or measure every single thing. Once I have gathered the data, once I have gathered the process information, then I move toward the next stage. It is basically the explore stage. Now I'll be observing the entire process. I'll be trying to find out the value and non-value adding processes. What is basically value and non-value added processes? It's like what should be the position of the machine which is going to stitch the shoe, or the machine which is going to glue the shoe. Uh, what should be the exact distance between these machines, or how many employees should be required, either one employee is enough or not. These are basically value adding in the value adding steps in the process. Then the bottlenecks, what can be the problems? Bottlenecks are basically those issues due to which our process can be choked in a long way. Or let's suppose I have an order of 10,000 shoe, and The raw material I don't I'll be needing it will be definitely huge, and I haven't figured out about that, like I'm going to stock the raw material or I'm going to apply the just-in-time approach, JIT approach, which on which Toyota is working. So if I haven't that figured out, then it will be a huge issue for me. My customers will be asking me for the order of 10,000 shoe in a week or two, and it will be taking almost a month just to manage the raw material. That will be an issue, or that will be the bottleneck. So I have to make sure that never happens. So for that, I'll be trying to manage the alternate paths, and then I'll try to refine all the requirements. Then I'll be developing, the next stage is develop. Then I'll be developing or designing a process which will have near to zero chances of error. I'll make sure that the work flow properly without any problems. All the issues are taken care of. The structure of process is properly implemented or well documented. And then at the end of the day, the last process, the last stage is implementation. I will do the implementation of entire process which I have made or I have created on papers or which I have experimented. On the basis of that data, I will implement the process, and I will make sure that in case the problems which uh, I just imagined that those problems can happen, or I just found out the problems, these specific problems can occur. I have to make sure that it must be taken care of once the implement is and the process is implemented. All right, the five steps roadmap is basically the summary of the implementation of Six Sigma, how we can implement it. The five-step uh, Six Sigma roadmap is recommended for any organization that wants to start implementing Six Sigma system through the organization and become a Six Sigma organization. The roadmap is basically very simple. First of all, the first step, which you can see, is identify core process and key customers. Like, what are the basic processes of any organization, or we can say who are the key customers. In case of hiking shoe, we know that the core processes must be cutting of the leather, cutting of the material, and then designing. First of all, the designing of a shoe, stitching of a shoe, and the gluing of the material involved in the shoe. Who will be the key customer? Of course, the mountain climbers or the hikers will be our key customers in this case. So we need to identify this thing. This is like taking a stock of what is going on in the organization as preparation for the next step. The next step is basically the defining customers requirement. Now I know that my customer will be the climbers or the hikers. What are their requirements? What exactly they expect from us or from our product? Of course, they want our product to be durable. If they are going to the area where it is most of the time raining, though, so they will be expecting from our product to be non-slippery. Of course, the statics, the design must be good. So these are some of the requirements, but we have to define all the problems where I have to write it down, and we for that we have to ask the customers. We might need be needing to interview different climbers or hikers for that. Now, the third step is basically the measuring of the current performance. In this step, the performance of each process is evaluated against the established needs of the customer for the products created. Like it will be like testing of your product, and the ideal or the main thing with which you will be comparing will be the customer's requirement. Let's suppose you have manufactured the shoe, and now you are going to check you are going to test your shoe as per the requirement of customer. Is it water resistant? It is waterproof or not? Yes, it is waterproof. If it passes, then okay, you are going to check if it is hard enough or durable enough that it won't crack after if we are hiking for like 1 or 2 hours. So yeah, the basically process capabilities can be expressed in terms of the numbers of sigmas. Like uh, you have to check the shoe, the number of pairs pass the test, then you can calculate how many pairs has passed the test and how many has failed by using the previous method which we have discussed. How we can calculate sigma, we can find out the sigma level at that stage. At every stage we can find out the sigma level, and we can then compare uh, later on. The fourth step is prioritizing, analyzing, and implementing the improvements. Of course, the improvement or making changes is a continuous process. The requirements of customers keep changing, and the systems are they keep updating with the time. So in this step, priorities are established among opportunities for improvement, and the improvement projects or design redesign projects are completed by teams, resulting in optimal solutions. The solutions are then implemented to obtain better process performance and customer satisfaction. Alright, the first step is expanding and integrating the Six Sigma system. As I've said before, that it is a continuous process. So achieving Six Sigma performance for an entire organization as opposed to uh, achieving Six Sigma performance for individual process is the objective of this step. Like we have to consider every single process or step as an entity with which we have to achieve or where we have to achieve the Six Sigma. If there is a process, like let's suppose if there are four processes and three processes are working efficiently but one process is creating defected parts, then the entire system is useless. Like the sigma level of entire system will be lower. So we have to make sure that the every process or the all the processes are working efficiently and the Six Sigma is implemented on all the processes. Process controls must be established where improvements have been obtained. Of course, with time, we need to do that. We need to make sure that there are control charts or there are process controls, there are methods to control the improvements which we have already made. If we don't establish a system to control what we have done, what we have changed, then the entire working which we have done is of no use. So we have to make sure to establish a system with which we can control the entire process or which we can control the changes which we have made. Okay, the culture change in the organization toward a commitment, a culture change in the organization toward a commitment to applying Six Sigma principle to all the business process must be established. Yes, it is not like a one-time thing. We have to make a culture of a Six Sigma in the organization. We can do that by training our employees. In our organizations, most of the employees don't have any idea what is Six Sigma. So what can be done? We have to arrange proper trainings for them. We have to educate them. We have to tell them the importance of this process. In our organizations, most of the people, if we talk about the implementation of Six Sigma, most of the people respond us like, we know better because of our experience. We have experience, so of course experience matters, but it's ignorance if you don't learn new tools for the improvement of process. Only experience is nothing. Experience cannot help you without proper implementation or learning of new tools. So continual trainings of your employees is very important, and the implementation or the creation of this culture of the accepting culture of accepting the change is very important. This is what exactly Six Sigma teaches us.